So entire screen, I'm going to share this one. Okay, I hope you can see this. It's a slide. I'm going to start from here. So welcome everyone. So today what we are going to see is these 2 points, which are very long points. So the inspire of these points is basically what we have done in the previous session when Nipyandra basically what has done is to develop a model using MLflow. Here we are going to do somehow the same, but with the approach of using Jupyter Notebook, which I think is very worth in terms that you will see the benefit that you can test out things and you can change things with the benefit of a Jupyter Notebook. And then after that, you can run MLflow to tracking and see all the changes and get all the parameters if you are a data science or you are new in data science. So this is the first step. So basically what we are going to cover is all the steps that already has been done in the previous session, but using a Jupyter Notebook. There is something that I will add. We are going deeply in this point after a few comments for the second point. So the second point is to deploying an MLflow model to Kubernetes. A spoiler alert. Let me tell you that the model that we are going to deploy in the first step is not the one that we are going to deploy to Kubernetes. Why? Well, unfortunately, I hit some issues that I couldn't debug on time for this session. So basically, I found the benefit to deploy MLflow in order that you can see how it's deployed. It's maybe the easiest step of this pipeline. But unfortunately, I couldn't make to deploy the first model that we are going to work in the first step. So
no worries. I think that's okay. We'll try to debug that. And yeah, the Jupyter Notebook thing, right? Somehow I'm still not comfortable with Jupyter Notebook per se. I mean, this is the first time kind of trying out notebooks, right? So all Vim, all the stuff. So I know that in the last session I may have tried Jupyter Notebook, but I'm getting there. So as
it's worth the effort. Once you get sort of into it, it will really help you with the machine learning Python coding.
Yeah,
it's worth the effort. Just keep plugging. You'll get it.
Yes, sure. Yes. So
or use the plugin in VS Code, and it puts you maybe in a little more familiar territory if you run the plugin in VS Code. But it's really worth it.
Yeah, so what I'm doing right now is I've put up another server on the cloud. There I'm putting all my notebooks, and I'm actually trying out a few things there. So yeah, I'm liking it. It's just that the feeling of that has not come yet. Hopefully it would come.
Okay.
Yeah, and unfortunately the book is a nice book. The problem is that it's using a specific framework, which is sometimes convenient and other times you need to go for this route that is basically to follow the book and build yourself your own framework. But let's move to the next point. Let's develop a model using an MLflow with a Jupyter Notebook. So what we are going to cover is something that is well documented. If you go to MLflow webpage, you will find that there is a specific user guide to doing that. And I prefer, I don't know you guys, but if I start to understand something, it's because I can read what is already documented and then try to clone the steps and trying to do with a different model. And this is what I'm going to do today. So rather than use the data and the model that is in this user guide that we have here. Sorry, where is the point? Here is it. This, I'm going to follow those steps. I'm going to summarize the step. Basically, what we are going to do is to go from the step 3 to the step 6. And what we are not going to deploy that model in Kubernetes due to the issues that I mentioned before. But what we are going to follow is these steps, this guide, and customize in a Jupyter Notebook, which is something that is not clear in the user guide. So the first thing that we are going to go to do is to have a look to the user guide. So this is the user guide. It's well documented. You can follow all these steps. There is one step to create your own Kubernetes cluster that I have already documented and I have in a repo. So after this session, I will share the link to the repo so you can follow those steps and you can do, or you can reproduce what I have done, which is basically a custom version of what we are going to see here. This is the step of the training model. What they're using here is a public model that I found out later is basically what is trying here is to train a model to define the quality of a wine based on some features. I will show you later when we are going to deploy this into Kubernetes. I will show you what is the model that they're using is. I think it's kind of a final project in one of the American university. We will find later. So this step we are not going to cover today, but basically what it's doing is just in Python to run all this sort of line and then call to the MLflow, start run and tracking the model inside of MLflow. We will do that, but in a notebook. Then, as we covered in the previous, we will run the MLflow user interface, and we will see all the parameters that we have there. This step is something that I found interesting, but it's because it's using a specific model, and makes sense this step because it's trying to find the best parameters to tune the model, which is something that we are not going to do today because the model that I'm using is the hard-to-see that I covered in a previous session that I did, which is basically a classifier model using the regression logarithmic classifier model. I think so. I don't have the name on top of my head, but we will see later. So this step is not covered in the Jupyter Notebook, and this is one that we are going to explore. What is how is packaged the model and how is packaged the model in a public store, and then how we are going to deploy into Kubernetes. We are going to cover this step, how to test in a local environment that the model is performing correctly. And that's pretty much. This is something that we are going to do in the second part of the session. So with further ado, let's go to the repo. I have already here. So let's go first for the README file that I have here. Let's move this in this one. You're going to follow Candlefor. So after this session, I will share the link to this repository. In the README file is documented all the requirements for run this. So the first part is this one, is basically deploy the model.
Can you please increase the font size if it's okay?
Sorry?
The font size can increase a bit.
Yeah, sure. Can you see now?
Yeah, it's better, yeah.
Perfect. So basically what we are going to, so here is well documented all the links that I already put in the slides. So you have already here all the links. Here you have the requirement section. Basically, I ran this with Python 3.10, which is the default one that I have in my Ubuntu laptop. So I didn't want to change the framework. Maybe that is the issue that I explained, but I don't know. It's pure guessing. So well, this is how we use a step. We prepare a virtual environment. Here we have the requirement for running all the steps, which is basically to run MLflow. This is for the testing part, and this is something that we need to have for running the MLflow to test the model, which is something that is required. When you are doing this from the scratch without this repository just for yourself, you will find that it will require to install this. And there is another additional requirement that I need to have in my Ubuntu, is that to install the I think I have here in the, no, okay, I need to add that link. You need to install the Python environment, the book, something like that. I will share the package that is required because it's already listed out here. And when you try to test locally the model, you will find an issue that is basically the issue is that is requiring that you have already installed in Ubuntu a specific package. So let's move to the Jupyter Notebook and let's start to run on the step. So if we go here to the Jupyter Notebook, I will close this because it's consuming a lot of space. So as I mentioned, I'm sorry if I'm repeat myself, but one of the things that I learned during my career is the first thing is to manage the expectation. So say what is out of the scope first, and after that, moving on. So once again, I remind you that in this part of the session, we are not to deploy the model to Kubernetes, specific this model. So here you have, again, the links to all the data that we are going to use. This is the user guide that we are going to follow. And this is the model that we are using, that basically is the one that I used in the previous session, that I ship this model inside of a Docker container. So basically, just a short reminder what is going on. What we are going to predict is that a person is very likely, but not in terms of the probability. If we're going to see to predict if it's likely or not, is yes or no, if has a chance to develop a coronary heart disease based on these features. So some of them are so very specific that I don't dare myself to to go further in trying to explain, but somehow some of them are very intuitive, like the obesity, the alcohol, and the age. The other one are and the family history, which is basically is that to record once again is a kind of yes and no feature, in terms that if there are previous member in the family that has developed a coronary heart disease. So that's pretty much the model in a nutshell. If we have a doctor in the in the audience, maybe he can go further and explain all the features, but we are not going to spend more time on that. So this is the model. We are going to like a kind of 10 features. When we discussed it in the previous session, is that this one, the SPP, after analyzing all the features pair to pair, somehow we figure out that this one is not correlated to anyone, so why we are going to add more noise to the model. So basically we conclude in the previous session that basically with these features we are going to try to predict if a person is very likely to develop a coronary heart disease, which is very nice. So far I remember the second model that we are going to see in this session, which is the wine quality. All the features count. I mean, there is it's like that has been a previous step in the pipeline, that is the engineering feature that has been already done. So basically we are going to run a model that is already created and so on, and all the features are already there. That's why we are going to deploy to Kubernetes straightforward. So let's go to the Jupyter Notebook. So the first thing that we are going to do is to run the MLflow server in order to have running in the background. So I found a little bit creative and I decided to create this step here, which is basically is running. So if I use, if I'm going here and type localhost, so now we have up and running. So I already cleaned, we don't have any experiment here. So this is the first step. So it's working pretty well in Ubuntu. I didn't test it out on other platforms, but it's very likely that will work. So as you can see, the output here is that it's already confirmed that you have the running and the process ID that is running that. So the first step is let's load all the library that we are going to use from MLflow, Panda, and all the things that are involved in the code. So let's do that. I love always to do this in the first step in order that then avoid to import, and I prefer to do this in the first step. Maybe it's not for me it's convenient. Maybe it's not a best practice, but this is the way that I follow. Then what I'm going to do is to load the data that I have already here, which is belong to the model that we have already see, which is this one. Here, in one of these steps, you can figure out from where is coming the data, and then I have downloaded and added to the repo. So basically what we're doing here is just a classic Panda operation to read the model, sorry, to read the data, and to have a preview of the data that we are going to run here. Then after doing that, we cannot work with this. This is something that we discussed in the previous session, that is basically we have to transform this column, which is the family history, because it's a kind of level column, and the model that we are going to use is the logistic regression. and all the features that we need to use are numbers. So we cannot use this feature. So basically what we are going to transform this column into numbers. So the best way to do is just because we have to label, or to label, we can say in that way, we are going to transform to 0 and 1. This is a kind of a random decision that we have made, but is using, I find out that there is even a kind of feature in MLflow to run as a step that is basically to take this kind of column and create a kind of random way to convert these columns, like family history, in numbers based on labels. But I think it's something that we can explore in another session, but it's very interesting. So after doing that, let's see that we have already transferred the data. And here is the step that we are not covering, that is basically to decide where are the features that we are going to use to work. We are not using the SVP because it's something that we already discussed in the previous session. And doing that, this is something that I took from the previous session, from the previous session, and even from other documents that I found out. Is a kind of to create some sort of metrics that we are going to record in MLflow in order to assess if the model is good or bad. But let me warn you that I'm not a data science. So here what we are using is basically to use some mean square error, which makes sense in order to see if we are creating a prediction with a lot of errors or not. So as long as it's close to 0 is better, because that means that the lack of error is shorter. So, but I'm not going to explain why I'm using that. It's basically I found very convenient, and so far I'm aware, I think is in the user guide that we are following. So I found very convenient to have it here. Just in the future, you want to run a second iteration in this repo, or I'm going to run a second iteration in this repo. I have this metric already here, and maybe I can assess if the prediction of the model is good or bad. So the next step is basically to decide what are the features that we are going to use. So basically, as an X feature, if we if we picture the model in a Cartesian, in a XY axis. So the XY will be all the features that we are going to use, and what we are going to predict is the Y-axis, which is the probability or the likelihood of someone can develop a coronary heart disease. So this is the normal step, that we split our data in test data and training data in order to run the model. Here we have some variables in order to if you want to change the name of the model, or you can work with this, because we are using this variable in order for tracking the model. So for instance, if we want to run this cell but change that is not the default one, is another version of the model that we are tracking, we can manage already here rather than write it straightforward here. So somehow we can track different versions. So let's run this one in order to split our data. Then let's record our first experiment in MLflow. So here is a typo. So I'm going to change here, and then I will push the change. So this is MLflow experiment. So if I run this one, let's check it out. Oh, nice. And we have the first issue. It is not enough values to unpack. Oh, okay, it's because I missed out this, sorry. So if I run again, okay. This is the demo effect, has been working all the time. Now it's not working. Sorry about that. Why is not working? Why is it that is, what is this? So we have here this, let me load again this, just in case I missed out something. This one is why?
It is saying that error, right? It said older version of scikit-learn is being used. If you come down to the message, right? It
Okay.
says
Yeah. Give me one moment. I will clean the. Let me. And now I will. Sorry, say that again. What do
so
you?
look at
What,
the message there, right? Auto logging. What's the warning only? It's okay. It's okay.
not enough
Warning.
knowledge to. Yeah, but this is something that has been
Yeah,
working. So expected to, and now it's not working. So if but the problem is that it's affecting that it's not deployed the. So let's have a look to the experiment. So if we go, it's not well. We can take out the auto login, but we are going to
Wait a minute.
listen
Wait a
up.
minute. Can you go to the message again?
So let me run with this. You know,
A list index out of range.
but log run. So, but this is something that we are doing. Yeah. But now is now that we have the experiment already. So let me check it out that we have the. So we have the experiment here. Yes, we have the experiment here with the artifacts. Okay. So I know that I have changed some things before to the session. I reset out the notebook, so maybe I'm using a. But this is an error, an issue that I haven't hit before. So basically, the feature auto logging is something that we discussed in the previous session. Is just when you run an experiment, by default, MLflow takes some metrics of the model, preload some metrics of the model, and then track those metrics with the model in MLflow. So let's move on. Let's go to register the model, and we will see if we experience the same issue. But
So you
yeah,
remove the auto log part and it worked, is it? I think it still failed.
yeah, it's still failed, but for whatever reason, now it's deploying the experiment.
Okay, now we can see that on MLflow dashboard.
Yeah, but it's not deploying with the full things because it's not deploying the data. So let me check it out. Something that I have, maybe I have done wrong here. From here. So this is one of the things that MLflow experiment. Uh, So, okay, let's move on. Let's run the next one because basically what we are going to do is the same that we have done previously, but recording the model. So let's see if we have the same issue because the interesting one, we still having the same issue. I know it's working. So, okay, let's see. Sorry, let's check it out that we have, sorry. So this is working. So, and this is the one that we need working and I will explain. Sorry about this, but localhost. What did I do wrong? Okay, perfect. Localhost. Okay, here we so perfect. This one looks like that is working. Let me check it out. So yeah, we are losing the metrics, and but we have the artifact, and let's check it out the mobile version. So I will explain. Okay, okay. Sorry about this issue, but this is something that is happening live. It didn't. It worked all the time. So let me do something live here. Like is take this line. Sorry. From here and move it and put it in the next cell and let's record it. And I won't explain. And I'm going to explain what is doing this. Okay, let's run this again. Yeah, it's just this line is failing for something that maybe that's
This particular line should not be with the function. It should be after the model. So it should not be with MLflow. Can you
yeah,
put it
you
here? Yeah. Let's try
here.
that. Yeah.
But let's try just for no, but it's still failing. Okay, no problem. So no problem. I will fix out this, and then when I share the link, you will find. So basically, this line, what it's doing is filling up this section of the tracking of the model. Now it's filling this one just because filling. So basically, the auto log line, what it's doing is just to log this here. To include some metrics to preload some metrics that provide the MLflow and put it here. Basically, the metrics that are in here are basically okay. No worries because I think I have here a screenshot, and we can. No, we don't have in this screenshot. No problem. So let's move on and I will explain. So basically what it's doing here is just to some low metrics about the score of the prediction, which is basically some formulas that I already searching today, but I found that it's not convenient to add here because it's more for a data science person. And if we are going to work in the operation side, basically what we need to be aware of some things that I'm going to explain later on is just the signature of the model, which from my point of view is very convenient. So let me recap what has happened here. So basically what we have done is in the previous step is just run a training. And in that running part of the training is just to record some metrics about the model. And for whatever reason, it's not working now. Then what we are printing here is just the same metrics that we already record, we put it here. But unfortunately, this is failing now. I need to figure out why it's failing and has been working all the time. It looks like that some part of the data set is not working in this moment now. And I need to figure out. The second part is basically to logging a model. What exactly means logging a model? It's something that we covered in the previous session. If you watch the video, you can see that was already run an experiment, and then you have the option when you have here the experiment and you assess how it's going the experiment in terms of the model metrics and the artifact that you get. This one, unfortunately, is the one that is failing. I'm going to take this one. You have here that you can manually register the model. So when you have registered the model is when you can serve the model, you can consume the model. So basically what we are doing here is in a programmatic way in Python, what we are doing is to run the experiment and log in the model of that experiment. So basically in a nutshell, we are running two experiments. Just the first experiment is just for the sake to exploring how it's performing the model. And the second experiment is once again to run the experiment to get the model, but at the same time to record the model or to log in the model in the tracking system. So I don't know if there is any question about that, what we are doing here. Okay. So now that we have already we have a model that we can serve, that is this one, the last one. We have here the artifacts. Nice. It's getting bizarre, this. Oh, sorry. This is, no. Sorry, no. Sorry. This is a previous window that I have before this session. So that's the problem. I have it more than one window. Is this one? No. is this one, exactly. So now that we have the model already logged or tracked here, let me explain something interesting about to record the model, which is a line that is in the code. Here in before testing out the model. Is this one. In the signatures of the model. What is exactly the signature of the model? If we go to this link, this line is very convenient because basically what it's doing is to read the model, the input of the model, and the output of the model, and create a kind of metadata of the model in order to define what are the type of data and even some metadata about the input that you're adding. So if we go here to the model, we should see here that if we go to the inputs, all the inputs are already identified, even with the name that we have already provided. So in previous session, what we have done is basically to take out the name of the column, but here we are adding the name of the column in order that if we are going to consume the model, we need this layer of metadata in order that to create an application that know what is going about in terms to get the prediction. So this is very inconvenient, and the output by default is this one, which is the type of data TensorFlow, but it's an integer. So this one is something that I couldn't achieve to change to customize, but so far I'm aware you can do exactly the same. You can put here that is the type long or an integer, and you can even give the range, that is used for this. So the main takeaway of this part is to use this line to create a kind of default signature of the model, which is basically is to identify the input and the output of the model. Any questions about this? Which is basically this one. You can customize later on. Even when you have the model, you can interact with the model already recorded and change whatever you need using this signature feature, which is very, very convenient to use. So let's move on. And if I run this again, maybe I will have, no, because this is the preview step with the autolog. Okay.
So Francisco, can I try something on you? Okay, so the example that comes to mind is the dog-cat image classification training.
Mm-hmm.
To get the dog-cat, or for people who are familiar with that, you get 10,000 images of cat, 10,000 images of dog, and you train the model to recognize dog versus cat. And to train it, you have to go through a couple times to get the training right. You have to pick the right number of epochs. And you have to pick the right training rate, and there's a couple other parameters you have to pick. And you keep iterating until you find the right combination of epochs, batch size, training rate, such that the model returns the greatest number of hits on the test data. And so I was like, I've been using Jupyter Notebook to just sort of, let me change this and retry it, change this, retry it, change this, retry it. It looks like MLflow would allow me to have a structure around my iterations to get the model right.
Correct. And somehow this is the goal of this session, is just what you are doing, you can do it. But if you refactor your code and start to add MLflow, the benefit that you will find is that each iteration that you're training, you're already tracking here.
Yes.
So
rather than just history that gets overwritten in the Jupyter Notebook, I'd have a record.
So we covered that.
So that's why I come. That's why I come to this book club. I learn something new every day. It's amazing.
So here and I don't know what is the outcome of the model you are training, but if the outcome at the end is something like this, is the outcome. Sorry, my voice. The outcome I mean in terms of the package that you get when you create a model. If it's a file like this, a pickle file, and then you have the definition of the model like this. So MLflow will help you to track each iteration, because basically what you are what you are recording here is all the things that you have already changed to get the parameters. And unfortunately, I would like to show you the metrics that you can record as well, because you can add the metrics that you have already described to the tracking system. So each iteration that you create in this section of here, the metrics, you can record every metric that you want. So if at the end of your Python code, you gather some information of the model, you can record already here, so you can go in your history and see which one has already working.
Yeah.
So MLflow, I cannot, unfortunately, it's just because it's failing today, the autolog, for whatever reason, I cannot show you. But I hope if we have a spare time discussing something, I can find what is failing. But here in this section, you, I don't know, maybe most of the model, they have a kind of training score. So that training score you can put here, and you can see in each step here. And even something amazing is that when you are here, you can, for instance, in this column, this is the one that I want to, here, you can add one specific column with the metric that you are recording. So one of the metrics that if you enable the autologging is the training score, you can add the training score here, and you can see the full iteration, all the iteration that you have done with the training score as a column here. So you can pick one is going better.
Okay, my first pass through my cat dog exercise got me a accuracy parameter of 60%.
Okay.
And I had to change the learning rate, and I had to change the number of epochs, and I eventually got up to an accuracy rate over 90%.
Okay.
But it took me a few tries, to get the right combination. And I'd imagine MLflow would have kept a record of each of those steps.
As long as you are able to, as long as you are able to track that metric in the metric section of every experiment, you can add here in the column.
Yeah.
So it's very visual. That's why I want to run this session with this, because I found a kind of entry point if you want to study a little bit of data science. So now you have a kind of setup that you can start to tinkering with different models and start to tracking how they perform. So I think MLflow is very worth in time to have it here.
Okay.
So let's move on to the next one. So the next step is to test out the model. For testing out the model, you need to run once again the MLflow server just for testing. So basically what I have this step here is just given the command that you need to run separately. So let's open here a session. So I'm going to put here the, okay, it's because I'm not, oh no. Okay, I know what is happening. So source okay, I have lost the, okay. I know what is happening now. I cleaned it, anyone can figure out what happened? Any guess? I can tell you, it's very easy. It's because I missed out this step. I cleaned the repo. Because I cloned the repo from GitHub in order to have cleaned it. So basically I need to create the virtual environment in Python. So sorry about that, but now I figure out what happened. So let me do that in a nutshell, because it's an easy step. Sorry. But at least I know what was happening. So, okay. Oh my goodness. Why is not copying this line? Okay, the problem is Python 3. Bloody. Python 3 here. Okay. So let's do something is.
Do you need to do pip install your requirements again?
Yeah, I need to do that, but before that, I'm going to kill as well the MLflow server in order to start a cleaned environment. So I'm going to run a good point. So I need to source bin active. So it's pip or install. Sorry about that. It's something that thanks that failed the how to start the MLflow, the second instance of the MLflow. I figured out that I didn't have the virtual environment Python, the Python virtual environment. So that was the issue since the beginning. Maybe I have MLflow as a library in my default Python in Ubuntu, but I don't have all the dependencies that I need. As you can see, is
Okay, so I think let's quickly go back because we're 10 minutes left, and then if you can go back to the steps, right? After that, what we'll be doing it, we can explain, and then we'll follow the steps after that quickly.
Yeah, we will run rapidly. So now what we need is the first thing is let's check it out that we have the server already. So we don't have an MLflow. So let's start the MLflow. So we have again starting. So let's run all the steps. So this is something that we have already discussed. So let's check it out this. And now it's working. Sorry. Sorry. So sometimes I want to have everything clean at the environment that I missed out. That important point is that to set up the environment first. So let me recap. The issue that we have hitting is just by default, somehow I have MLflow in my Ubuntu install, but I didn't have all the dependencies that basically what I missed out is this step. So if someone is watching this later on recorded, all the issues that we experiment is just because we have already done this, because before running the session, I already delete the Python virtual environment. So now
you should add the source. You should add the source command in there too.
Yeah, sure thing. I will do. So
no, it's okay. I'm telling you, I have the same problem. You just forget.
Yeah, so now I can fully explain. So now the autolog is already working, so we can explore again the model. So this is all the metrics that I already told before. Go further in details of the metrics. We require that you have to be a data science or experienced person in data science in order to understand what's going on. But maybe the easiest one or the intuitive one, all of us, assuming that we have already involved with mathematics, is this one, the absolute mean error that somehow can figure out how good is the model that you are working. So something that I mentioned before, Jack, is if you do this and add, for instance, the training F1 score, which is one of the default metric that is added, you can start to track all the iterations and you can have here that metric. So if you refactor your code and start to involve MLflow, it would work. Even I will add the code so you can copy some steps that I have here and adapt for yourself in order that you can have MLflow working in the background and then you refactor. Let me warn you that there are people that train the model before this step, the start run, and I don't find any difference there. So what I mean is that you can find a lot of code with this line here, which is the model running before the start run experiment. And didn't find any difference because basically the start run and the login step, basically what is taking is the value of the model that you have already created and tracking the system. So what I mean with that is that you will find code like this one that I already done, but you will find different code that basically what is doing in the start underscore run is just recording what has been done previously. It's just warning you about that. So if we run this step now, we are going to record a new version of the model if we don't experience an issue, which is not, which it will be the last one, this one. And we have the model already recorded here, will be the version 3. We have the inputs and all the metrics that you want of the model is in the experiment side. You don't have in the models section. So basically here what you have is a kind of metadata of the model. So okay, let's move on to the next step because somehow we are on time. So let's now to run again the command in order to run the MLflow server, the second instance, in order to test out the model. So if I'm going here to this session with the Python environment, now everything is working smoothly. My goodness. So we have the second instance of MLflow server just specifically to test it out that we can consume the model. And the way to do that, I developed this cell in order that basically what it's doing is to run a cool command to a request, a post request in order to get the result. So if we run this one, we get the prediction. If you remember the last session, basically what we're doing is just to predict the first row of the table. So if you go here and see and track the data, you can see that we have somehow the tobacco. If you keep in mind the alcohol is 97.2, you will find out is the first, and the age is 52, and the prediction is 1. So now in this cell, we can start to work with the model or to tinker with the model, say, okay, let's move on this to 6, and then this one to 38. And maybe this one, and keep the other variables. So if we run, we have a prediction that this person is not going to develop a coronary heart disease, sorry. So we have finished somehow in time the first part of the session. So now, if we have this model up and running, so let's back to so basically what we have done so far is just to follow this user guide to start to use MLflow with Jupyter Notebooks. And then what we have explored is the signature of the model, which is basically to create a metadata layer that is convenient because the model will be served with this metadata layer in order to be consumed. Because if we are going here and we explore again this part of the model, if we go here to the last experiment that is recording the model, we can see that in the artifact section, in the ML file here, we can see that we have the definition of the input and we have the definition of the outputs. And if we want to add some parameters to the model as well, we can track that. It's something that I haven't explored, but you have, I find very convenient. It's just to add that line, you have this. You can customize in terms that after record the model, then you can start to work on the model and to add more information using the signature of the model. But it's something that I'm not going to cover here. So let's move on to the second part of the session. Oh, okay. And this is important for me. And I think it's very important for all of you in terms that why we need to add that because in the previous session, when we start to play with this idea of create a model and then put inside of Docker. When Nipintra did that with a regression model, you only have an input and an output. But when you are using a model like this, that you have many inputs and only one output, it's very important how you provide in order to consume the model, the order that you provide the parameters. And it's something that I learned in the hard way. And I have to add this line in this preview exercise of trying to serving a model in a Docker container. So that's why the signature is very important, because if you want to not to use this framework and just to build your own framework, at certain points you need to be aware the order of the feature, because the application that is going to consume the prediction of the model, will need to use we need to know what are the features, what are the type of the features, and what are exactly the order of the feature in order to create a proper prediction. So that's why I added this line here, is because I learned the hard way that if you want to build something from the scratch without using this kind of framework, at certain points you need to be aware about the metadata of the model. So that's the takeaway of this point. So let's move on to the next one. So let's go first. So what we are going to, so now we have our MLflow. Unfortunately, it's not the MLflow that we develop. We are going to use a public MLflow. So how we deploy MLflow model into Kubernetes? Well, the straightforward answer for that question is using Kserve, which is a platform that, if we click here, which is a platform that involves many things. It's a platform that that the goal is to not only to you can deploy MLflow model, any sort of model that you can imagine, TensorFlow model, PyTorch model, whatever you want to use. That is the main goal of this platform. It's something that I learned that is model inference platform. It's basically a platform that the goal is just to serve machine learning models without, serverless. It's using Knative and Istio in order that when you deploy something, you don't have to deploy a container that create an ecosystem or a runtime for the model. Basically, what you're going is to create a custom resource with information what is the model, and the model will be a straightforward deploy. And we are going to do that in order that you can see how it's easy to deploy a model using this.
Francisco, how
Yeah.
much time we will take, because it's already our 1 hour finished.
Oh, I
I
hope.
need
This might be
to.
a topic for next time. This is really interesting. I've never. Is Kserve widely known, or is Kserve purely in the machine learning space?
To
Yeah, it
be
is a
honest,
machine learning space. It's there to serve the models. That is the primary job of it. It is widely known, so it is also part of the Kubeflow ecosystem as well.
Okay. Okay. Thank you.
Okay, so I think we'll take it
so
next time. We don't have enough time because I have a
yeah,
hard
Very
time
interesting.
close.
yeah. Sorry about that. I was tracking the time here, but I missed out that we start
I
half
think we
past
kind of
four.
went through a lot of repeat stuff from the last session per se, which is started from here, like after the model is being built. It would have been ideal to kind of just take it from here. But anyway, that's fine. Some folks have learned the stuff. That's okay.
Sure thing.
So we would basically cover this particular topic from the next time, in which we'll kind of course, look at what Francisco is covering with Kserve and so on. Also, we should kind of go back to the book, right? What we are doing there. So what we can also do is we can also look at the data part, what has been there. So I'm just trying to open the book. Not opening at my end for some reason. So if you look at in the book which we have been referring, right, ML on Kubernetes, they have an example of some travel thing, right? So we should try to cover that. I'm not sure why it is not opening. Anybody has the book open on their end? On their end?
Um,
No. Okay. Francisco, you are on mute.
Yeah, I'm mute. Yeah, I have it. So do you want me to share the book?
Yeah, please, please, if you can just open the book. Yeah.
Yeah, sure. Let me share the window. Here is it. So I have it already. So what chapter do you want me to go?
Yeah, so if you go to that chapter of MLflow, this one, right, where they talk about all the cleaning up the data and all that stuff, right? It's
The
not the
chapter
part.
9? No.
No, I don't think the next part. I believe the next chapter 10.
Chapter 10. So sorry.
Maybe,
We'll go to
maybe
teach.
I'm not too sure.
Yeah, build and deploy the model. No, build and
Correct,
deploy.
correct.
Yeah, and monitor the
So
model.
if you can kind of, yeah, Jupyter Notebook what they have given. Yeah, so start the server is perfectly fine. Where did they have a data there, right? There's some data which talking about, right? Yeah, and this is the one, right? Yeah, so basically what we can do is we can cover this part of um, the book next time, in which we look at what data they are saying and how what kind of model they are putting up together. And this would eventually kind of get deployed on the MLflow. What they would have also have a demo. They will also have talked about in this book as well, right? Because we want to kind of bring the learning and there. So I'm not sure whether you want to take it, Francisco, because um, as a covering Kserve, you can try this data set as well.
Yeah,
Um,
sure thing. Yeah, sure. Yeah, I can try it. No problem. Leave it to me. So, but let me to confirm. Maybe tomorrow or no more later month. So I will try to confirm before the end of the week. Just because, as I mentioned previously, I'm between projects, so I'm not sure if I can make it next session.
okay,
So
okay,
to
no
be honest,
problem. Yeah.
let me confirm before the end of the week.
Sure. So